Okay, so free fall is going to start our transition from one-dimensional motion to two-dimensional motion, because in two-dimensional motion, the vertical motion resembles free fall. So apologize, not moving forward. It's just all right. So the story goes that Galileo dropped objects from the Leaning Tower of Pisa to study free fall, and free fall is the motion determined by gravity alone. So what happens is the only thing that is affecting the object is gravity. So it's able to fall freely through the air under no air resistance. And so it's going to be a big thing for us here in Physics 1, is that there will be no air resistance affecting that object. Okay, and I just mentioned that, right? So for free fall problems, we're going to neglect the effects of air resistance. Now, objects in free fall will experience the same acceleration. So they don't fall with the same speed. They fall with the same change in speed, or a factor that changes the speed, and that's known as the acceleration due to gravity. Now, it's going to have a value of 9.81 meters per second squared, and is always directed downward towards the center of the Earth. Okay. And what happens is there's three types of free fall, and they're all distinguished by their initial velocities. Okay. So these three pictures show you the three types of free fall. So here you got the dad throwing his child up. And so when we say we're throwing it up, the initial velocity is going to be greater than 0, which means it's going to be positive, which means at the top of this child's motion, before it can come back down, it has to stop. Okay, that's very important in these questions, especially when you're throwing something up. The object stops for a very instant, okay, before it can come back down. And so they like to try to trick you with these vector questions. What happens? What is the vector of what is the acceleration vector at the top of free fall? Okay. Remember, it's always going to be pointed downward. Now, if it talks about what is the velocity at the top, now it's going to be 0. Okay. This one here is when the velocity is equal to 0. Sometimes you'll see it referred to, they'll say an object is dropped. Okay. And then ask you to find how fast is it moving, how fast is it moving at 2 seconds, how fast is it moving once it hits the ground, how high is a cliff or something like that. And then the next one is a basketball player. It shows, so here this is Luka Doncic in his Slovenia uniform. But when you dribble a basketball, you push it down, which means you give the object an initial velocity that is less than 0. So this is actually initial velocity, right? And so because it's less than 0, it's going to actually gain, a magnitude of speed, okay, but continue off in the negative direction, okay? With when you're throwing the baby upwards, that's not me and my child, so don't worry about it. So when you're throwing it up, it's going to lose speed until it reaches the top, until it reaches 0. In the situation with the basketball player, is that it's going to gain speed until it finally reaches the floor, okay, and bounce back up. All right, so let's look at some examples. So a soldier steps off the end of a 3-meter high diving board and drops to the water below. How much time does it take for him to reach the water, and what is the soldier's speed on entering the water? So if you think about it, you've got your soldier up here, right? They're going to step off, which tells you that their initial velocity will be 0. It's like a drop situation, okay? They tell us that this is a 3-meter high diving board, which is the platforms, right? It's one of the first platforms. And they're asking us, how long does this take? And then how fast are they moving once they hit the ground or hit the water? Okay. So in a way, in that picture, I've written my unknown. So if we want to find the time, okay, notice that we don't have the final velocity. So we're going to have to use the x equals xo plus VOT plus 1/2 AT squared for part A, right? Because we don't have our final velocity. And so our initial position is 0. Our initial velocity is 0, right? Because we're just dropping. So it means in fact, what happens with these is that we can change that now from an x to a y, right? And so we're going to solve this for time. It's going to be the square root of 2y over a. But remember, a is always going to be negative 9.81 meters per second squared. So you do have to be careful with this negative sign. But remember, this x equals xo, that is a displacement. So that is our delta x. And so if we're starting up here as our initial position of 0, we're dropping down, which means our y, or our height, is actually going to be in a negative number. So we're going to do negative 2, or 2 times negative 3 over negative 9.81 will give us the time. So 2 times 3 divided by 9.81, and then we're going to take the square root of that. Which tells us that it's going to take us 0.78 seconds to reach the ground, okay, or the water. Keep calling it the ground. We don't want the soldier hitting the ground. We want the soldier hitting water, okay? Now, what is the soldier's speed upon entering the water? Again, my recommendation is assume that this is wrong and find an equation that is missing our unknown, right? Or excuse me, that is missing what we were looking for in part A, which is time. So there's one equation that doesn't have time in it. Again, the initial velocity will be 0. And so we say v squared equals 2a, and we're going to call it, now we're going to change that x to a y. And then so this is the one step that students will forget, is to take the square root of this number. So we would say v equals the square root of 2 times negative 9.81 times negative 3.00. And so our velocity will be 2 times 9.81 times 3, square root, answer. Oh, I forgot the decimal. I was like, he's moving very fast once he hits the water. And so his velocity would be 7.67 meters per second when hitting the water. All right, next equation, or next problem looks at what happens if we throw an object up, right? And so we're looking at water. So we're giving this water an initial velocity that's greater than 0. And it's asking us a couple things, right? So this is kind of working backwards. They're telling us that that this height is 171 meters. And we're asked to find what is this initial speed and then how much time does it take to get to that point, okay? And so we're v0s are unknown. We know our final velocity at the top has to be 0, okay? And we're given the distance that it travels, or the displacement that it travels. So in part A, we don't have time, right? And so we're just going to v squared equals vo squared plus 2a delta x. And so I do a little bit of algebra. And the final velocity is going to be 0, so it's going to be v0 squared equals negative 2a delta y, right? I'm going to change the x to a y, and then I'm going to take the square root of that. So v initial velocity is negative 2 times a delta y. And don't worry about this being a negative under a square root, because remember, a is always negative 9.81 in free fall questions. So v equals the square root of negative 2 times negative 9.81 times 171. Now in this case, our displacement is not equal to 0, or excuse me, not equal to negative number, is equal to a positive. So we'll say 2 times 9.81 times 171. Take the square root of that. And we get initial velocity of 57.9 meters per second. So it's going to be a positive 57.9 meters per second. Now, this is a problem where, again, my recommendation would be not to use a possibly wrong answer, but you would need to use that here because remember, initial velocity appears in all the equations, so we have to use that. So we're going to use v equals v0 plus at, okay? Our final velocity is 0 at the top, and so we're asked to find the time, so it's going to be negative v0 over a It'll be negative 57.9 divided by negative 9.81. And so it tells us it takes about just under 6 seconds to get to the top. Now, they may ask you a second part of this question, how long does it take for to get up and then come back down? All you would have to do is double that time, because there's a saying in physics, the time to rise equals the time to fall.